Hey Algebra 2, today we are going to look at properties of logarithms. So we've set a lot of ground rules for logarithms, but now we're going to go through some properties of them. First of all, let's review what we've learned. Use the approximation of log 2 equals 0.301 to approximate the values of each of the following logarithmic expressions. Goodness. So this one I can break down into log of 2 times 10, which is log of 10 plus log of 2. Log of 10 we know is 1. Log of 2 is 0.3010. So our answer is 1.3010. If we get to B, I can say log of 0.2 is the same as log of 0.1 times 2, and log of 0.1 is negative 1. So we get negative 1 plus 0.3010, which gives us negative 0.6990. And then that last one, log of 2 to the 4th, that is the same as log of 2 times 2 times 2 times 2, which I can break down. Which I can break down further. Yes, you see the tedious way I'm going at this, which looks just silly awful. I'm out of room. Okay, that equals 0.3010. Oh, I can't even do it. 4 times. I'll go ahead and write it. 3010, 3010, 3010, which equals 0.3010 times 4, which is way easier than adding it 4 times. I've got 1.2040. The point with this exercise is that all is silly. We need to come up with a better way of doing things, and quick, because that's tedious, and we don't like tedious math. We like math that we figure out easier ways to do things. Okay, first of all, in all 3 parts of the opening exercises, we used this property, which we have learned already in the past. Log of xy is log of x times y, which equals log x plus log y, right? We also used this one, log of 10 equals 1, and this one, log of 0.1 equals negative 1. Those are the 3 properties that we used in the previous exercise, but we have more properties. If you remember, by definition, we came up with sort of a rule or a pattern that said if L equals log of x, then 10 raised to the L equals x. Because when there's nothing written here, it's always base 10, we just never, ever write it. Okay? Question, what happens when x is 1? Well, in that case, L has to be 0, because anything raised to the 0 power is, in fact, 1. What about when x equals 0? This is a question mark. When x equals 0, okay, that doesn't work. It's undefined. There's no exponent of 10. There's no exponent of 10 that gives a value of 0. Right? try another one. We're still at 10 to the L equals x. I just didn't write small enough on the previous slide. What about when x equals 10 to the 9th? So I've got 10 to the L equals 10 to the 9th. Well, in that case, sorry, L equals 9. Okay, what about when x equals 10 to the n? Well, I can rewrite it. 10 to the L equals 10 to the n. That means L equals n. Silly. What about when x equals the third root of 10? Well, that's the same as 10 to the 1/3, right? So we have 10 to the L equals 10 to the 1/3. So L equals 1/3. Okay, we got it. Let's move on. Okay, some exercises for us. For exercises 1 through 6, explain why each statement below is a property of base 10 logarithms. So property 1 says log of 1 equals 0. All right, so basically, because L equals log x means, 10 to the L equals x, then when x equals 1, L equals 0. And this should say when. If we have property 2, log of 10 equals 1, okay, because what we've said before, because L equals log x means 10 to the L equals x, then when x equals 10, L equals 1. Okay, how about this one? For all real numbers r, log of 10 to the r equals r. Remember, this is base 10 because we don't have anything there. This is one that I've always used a lot because L equals log x means 10 to the L equals x, then when x equals 10 to the r, L equals r. Okay, I'm going to write down here really quick. Log base 10 of 10 to the r equals r. When these are the same, this is your answer. Okay, and it works every time. It's pretty cool. How about property 4? For any x greater than 0, 10 raised to the log x equals x. Okay, that's because L equals log of x means 10 to the L equals x. Okay, then when x equals, it's not then when. Let me repeat that. So what I've just said is property 4, for x is greater than 0, 10 raised to the log x equals x. Because we know that L equals log of x means 10 raised to the L equals x. Then x equals 10 log x. Okay, that's another little trick. I'm going to put a little base here. When these two numbers match, that's my answer. Okay, it's one of those sort of just patterns that I've always known. Okay, 2 more properties. Property 5, for any positive real numbers x and y, log of x times y equals log x plus log y. Hint, use an exponent rule as well as property 4. All right, so we know we're going to do 5 right here. Okay, we know the rule, a raised to the b times a raised to the c equals a to the b plus c. That's our exponent rule, that's the hint, right? So if we apply that to our powers and logs, if we had 10 log x plus 10 log y, that would be log 10, sorry, let's get that 10 looking normal. 10 to the log x plus log y. And I'm terrible with those parentheses. Then we can use property 4 to simplify this. Log, oh for goodness sakes, I'm sorry. 10 raised to the log x times 10 raised to the log y equals x times y. Okay, we said for property 4, if these are the same, that's my sort of answer, that's my simplification. And if these are the same, that's my simplification. So I can say x, this group right here simplifies to x, and this group right here simplifies to y, which is what I've written right there. All right? And property 6, for any positive real number x and any real number r, log of x to the r equals r times log x. This is another one we use all the time. Basically, if we have a power, we can drop it in front of the log and make it the power times the log. Okay, so let's use some exponent rules to explain this one too. I've got a raised to the b raised to the c equals a to the bc. So if we relate that back to our logs, I've got 10 raised to the k log x equals, sorry, I keep writing log first, equals 10 raised to the log x raised to the k. Okay, I just pulled this k outside the parentheses because if I have a power of a power, I multiply them. Just like I did here. I have a power of a power right here. So a raised to the b raised to the c gives me a to the b times c. Same here. I've got 10 raised to the k log x. That means I have 10 raised to the log x, and k can go on the outside. It doesn't matter. Let's simplify that one more step. If I use property 4, that gives me 10 raised to the log x, all of that raised to the r. I have x raised to the r. And here it's because, remember, because I have 10 raised to the log base 10 of x, that simplifies to just x. So this right here simplifies to x, and that r stays in my power spot. Okay? Therefore, I can say that x to the r equals 10 r log x. By property 4, x to the r equals 10 log x to the r, because this r can go in front of the log, as it did right here. Let me write one more thing for property 6. 10 raised to the log x to the r equals 10 r log x, because I can drop that r in front of the log. So since the exponents are equal, this would be log base 10 and this would be log base 10. So I've got 10 with the power log base 10 x to the r, and 10 with the power r times log base 10 of x. I can write log of x to the r equals r log x. So this r can get dropped in front of it, which I wrote right there. All right, let's summarize these one more time. So the ones that we've known for a long time, I've got log of 1 equals 0, log of 10 equals 1. I can expand that out to log of 100 equals 2, log of 1000 equals 3, etc. New ones that we've learned, if I have log base 10 of 10 to the r, so this would be log base 10 of 10 to the r, when the base and the number that you're taking the log of, when those two match, your answer is the power. And here also, I've got 10 raised to the log base 10 of x. When the base here and this number match, then my answer is x. I simplify to x. We also can say log x times y is log x plus log y. We've got that one. And this is the one we just did, log base 10 of x to the r. I can put the r in front and say log base 10 of x. I'm going to write these one more time, 3 and 4. If I say log base 10 of 10 to the r, if those two match, I simplify everything to r. I can also say 10 raised to the log base 10 of x. It doesn't even matter. When these match, it gets simplified to x every time. Okay, and these are just we've done them, just not explicitly. Okay, this one right here is the same as log of 1 minus log of x. Log of 1 is 0, so it simplifies to negative log x. And here I can do log of x minus log of y when I have log of a fraction. Let's use them. Let's practice. All right. Apply properties of logarithms to rewrite the following expressions as a single logarithm or number. So I have a 1/2 in front of log 25 plus log 4. I can move that 1/2 into the exponent spot, remember? And when it's an exponent spot, then I can actually, for this one, take the square root of it. So this is the same as log square root of 25. Well, let's do this. Let's write out all the steps this first time. Log of 25 raised to the 1/2 plus log of 4. 25 raised to the 1/2 is 5, so log of 5 plus log of 4. That equals log of 5 times 4, which equals log of 20. And that is my answer here, log 20. And it says single logarithm or number. I'm log 20, so I'm good. Here I have another power. So log of 8 raised to the 1/3 plus log of 16. Cubed root of 8 is 2, so that gives me log 2 plus log 16. Log 2 times 16, which is log of 32. Makes sense? Okay, this one I'm going to actually have to cube something. Log of 5 to the 3rd power plus log of 0.8. 5 to the 3rd power is 125, right? 5 to the 3rd power, yep, 125, awesome. So that gives me log of 125 plus log of 0.8, or log of 125 times 0.8, which is 100. And we know what log of 100 is. It's 2. It's nice to get a little happy number, right? All right, now apply properties of logarithms to rewrite each expression as a sum of terms involving log x, log y, where x and y are positive real numbers. Here I would say like expand the logarithm. So this is really log of 3 plus log of x squared plus log of y to the 5th. But I don't want any powers. So if I have an exponent, I need to drop it in front of the log. So log 3 plus 2 log x, there's one of our properties, plus 5 log y. And I have my answer. Okay, let's go ahead and take that square root and put it up in the power spot, or the exponent spot. X to the 7th, y to the 3rd, all raised to the 1/2. Now I'm going to go ahead and drop that. Actually, let's go ahead and distribute that 1/2 into our parentheses. That gives me log of 7/2, log of x to the 7/2, y to the 3/2. Now we can expand it. 7/2 log x plus 3/2 log y. Cool. Awesome. In mathematical terminology, logarithms are well defined because if x equals y, then log x equals log y for xy greater than 0. This is important. I can take the log of both sides of an equal sign to try to solve things. This means that if you want to solve an equation involving exponents, you can apply a logarithm to both sides of the equation, just as you can take the square root of both sides when solving a quadratic equation. You do need to be careful not to take the logarithm of a negative number or a 0. So use the property stated above to solve the following equations. This is a property we're going to use quite a bit, but it wasn't stated explicitly during the property part of our lesson. So we're going to discuss it more now. So I can take the log of both sides of this equal sign to help solve the problem. So log of 10 raised to the 10x, okay, that's one of our properties we've just done, equals log of 100. We know that one too. So if I'm taking log base 10 of 10 raised to the 10x, remember we said this is a property. When these two are equal, I simplify to that. So that gives me 10x, and then log of 100 equals 2. X equals 2/10 or 1/5. 1/5 is your final answer. Does that sort of make sense? Okay, let's try this one. First, I don't want that in the denominator because I don't like it. So I'm going to go 10 to the x minus 1 equals 10 to the negative x plus 1. Or that would give me 10x minus 1, 10 to the negative x minus 1. Now let's take the log of both sides. Log base 10 of 10 to the x minus 1 equals log base 10 of 10 to the negative x minus 1. When I have log base 10, if those match, it simplifies here. If those match, it simplifies here. So x minus 1 equals negative x minus 1. Let's go ahead and solve it. Add x to both sides. Add 1 to both sides, it cancels out. So x does in fact equal 0. A little messy. Let's take this one to a new slide though. I have 100 to the 2x equals 10 to the 3x minus 1. So I can take the log of both sides but it doesn't really help me on this left side, except I can change it to 10 squared. I'm doing way more steps than I normally would, right? So now these match. And that's really important. I need those to match. So this is log base 10 of 10 to the 3x minus 1. Skip that. Log base 10, 3x minus 1. Oh, 10 to the 3x minus 1. So now I can say that 4x equals 3x minus 1. Subtract 3x from both sides. X equals negative 1. Sort of fun. All right, solve the following equations. All right, I'm going to take the log of both sides. Log of 10 to the x equals log of 2 to the 7th. So this one the left side simplifies to x. The right side, I can drop the 7 in front. Log of 2. And I'm simplified. Okay, I'm solved as good as I can. I can try to crunch that number, but it's not going to be very exact. How about this one? Log base 10 of 10 to the x squared plus 1 equals log of 15. The left side simplifies to x squared plus 1. The right side, log of 15. Subtract 1 from both sides. X squared equals log 15 minus 1. I can take the square root of both sides. So I have x equals, don't forget about your negative, plus or minus log of 15 minus 1. Okay, don't let crazy different things scare you. Just go ahead and apply your algebra skills and you'll be just fine. All right, how about this one? I don't have 10s. What do I do? Well, let's go ahead and try to take the log of both sides and see what happens. So I've got log base 10 of 4 to the x equals log base 10 of 5 to the 3rd power. I get x log 4 equals 3 log 5. Well, log 4 is a number, so let's go ahead and just divide both sides by log 4. Now the right side of the equation is a number. It's just sort of a messy number, but that is an answer. That works just fine. All right, there's the summary. I gave you the summary a few slides prior. Just throwing it out here again so that we can try to remember all of our properties. Properties are new and different to you guys, but the more you practice them, the more you won't have to look them up to figure out what to do. All right? Good job today.